One very important thing about vectors is sometimes we have to resolve vector into its components. Some vectors are very simple to understand. For example, I made some diagrams of over here. As you can see, this vector is acting parallel to the surface, and we normally recognize it as horizontal component or a horizontal vector, and it is very simple, and we know that the object will accelerate this way. And same you can say for this situation, because we can see there is a vertically upward acting force or speed or velocity actually, and there will be no confusion because this is simply vertical and this one is horizontal. But confusion begins over here. What will happen in this case? How will this force will disturb this object? Okay. For such cases, what we need to do is we need to split these forces into their horizontal and their vertical components. We call that resolving vectors into its rectangular component, and that is a very important technique. Now, this is how we do it. We complete a right angle triangle. Now, if this is vector v, this is a component of vector v parallel to the horizontal surface, and this is the component of vector v which is acting perpendicular to the surface, and it is vertically outward of the surfaces, or we can say vertically upward as well. So this is how we name vectors. This is called the horizontal component, or Vx. This will be Vy. So these are the horizontal and vertical components of the vector. Now, for the simplicity, I made a comparatively larger diagram over here for you to understand how to split a vector into its components, the rectangular components, I should say. Let's consider this is a component of, this is a vector of force, and let's name it F. This is a vector F, and it is acting at an angle of theta degree with the horizontal. Now, this is F's vertical component. Let's name it Fy. This is horizontal component of F. Let's name it Fx. So, this force F is acting at an angle with the surface. So there is a part of this force that is dragging the object along the surface, and there is a part of the force that is actually trying to lift the object off the surface. This is Fy. This is Fx. If we want to find out and a relationship between the Fy and F and Fx and F, we need to use this angle theta, and this is a very important angle in this case. Now, how do we find the horizontal and vertical component using trigonometry over here? Now, this is Fy, this is vertical component, this is F, and according to trigonometry, this is opposite to the angle, so it is Fy or perpendicular. This is opposite to the 90-degree angle, so it is hypotenuse. And the relationship between perpendicular and hypotenuse is sine. Hence, sine theta equals to unknown Fy divided by F. So F is actually, Fy is F times sine theta. Now, same story for Fx and F. It is cos theta now. Cos theta equals Fx divided by F. So if we make Fx the subject, it becomes Fx equals F cos theta. So these are the components along and perpendicular to the surface. Now, there is a third situation that is illustrated over here. If we put an object on a ramp that is inclined to the horizontal, if we put this object over here and let it go, it will roll down. Ask yourself, why does it roll down? If you think your answer is gravity or weight, then it is wrong. Because weight acts vertically downward. It does not act along the surface. This is the direction the weight is acting. This is the direction for weight. So if you think weight is bringing the object down along the slope, you're wrong. Weight is acting this way, so object is coming down this way. So it is not the whole weight that is bringing the object down. In this case, the vector of weight splits into two components, as illustrated, as will be illustrated on the diagram in a moment. Now this is what I was saying. These are the components over here. This is the component that is acting perpendicular to the surface, and this is the component that is acting parallel to the surface. Now this is the weight, and these are the components of the weight. Now it will be easier to answer the question that which force is bringing the object down. Is it weight? No. It is this component of weight, this one, which is acting parallel to the slope. This component is the cause why the object rolls down. Now, how can we find it? Using similar triangles, if the angle between the inclined plane and the horizontal is theta, this angle will also be theta. And if the black line is representing weight, which is mg, using the same notation as we did on the left side, the component that is opposite to the angle will be mg sine theta, and component that is acting perpendicular to the surface is mg cos theta. So which force is responsible for object to roll down? Now it is very simple for you to answer that mg sine theta is acting along the slope. So mg sine theta brings the object down along the slope. Here is an illustration of components of force. This is what we all have done. And this is what I say to my students, and I keep repeating this thing again and again. By nature, we are physicists. We are very good physicists. We understand physics, whether it is heat or light or force or speed or everything. We are very good in understanding physics. The problem comes when we have to tell somebody what we understand. So in the course of physics, we actually learn how to express, how to reflect that we understand. That's it. We are very good in physics by nature. And this one example. This is a heavy table with some things I try to draw on the top that to make it look heavy. So we all have done this thing. So this is you trying to pull the object or table along the floor, and when we cannot because it is heavy, you all must know that instead of pulling this object, right now this arm over here is exerting a force in this direction. So it is making an angle of theta over here. So that means a component of force is trying to pull and a component of force is trying to lift. But we don't want to lift the table. What we want to do is we want to drag. So we change our gesture a little bit. Like instead of being like this, what we do is we bend ourselves. We do this, and when we cannot pull the object, and you see there is a change in our posture. We lean down and now our arm is very much along the horizontal. And this is what we do when we cannot pull something. We bend our body, lower the angle of arms, and we drag the object, and we feel it the object is dragged along the surface more comfortably. You know why? Because now we have reduced the angle over here. Why reducing angle in this case helps? This is this is how we can understand that. It is all about the sine component and cos component. In this case, the horizontal component, or in any case actually, if the angle is from the horizontal component is force cos component, and the vertical component is forces y component or perpendicular component. Which one is we actually need in this case is this one. And from 0 degree to 90 degree, at 0 degree, sine 0 is 0 and sine 90 is 1. So that means from 0 degree to 90 degree, the value of sine increases from 0 to 1. The maximum value of sine is 1. It is opposite for cos. Cos 0 is 1 and cos 90 is 0. Okay, we never knew that about ourselves, that we are so good mathematicians and we know that we are changing angles and we are changing components, but actually we are. In this case, this person is exerting force more close to the horizontal. So what is happening is he is reducing the angle theta. Smaller angle means more cos component, less sine component, less force is used to lift the object, which we don't want to. We actually want to drag the object. So this is where we do physics without even knowing we are doing it. So as you change angle from 0 to 90, the cos component decreases and sine component increases. So it is opposite if you want to lift. Actually, if we want to lift, what we do is we take our body more close to the object and make the angle of arms more perpendicular to the surface of the board of the table, and what happens is we can easily lift it. And if you now feel that you actually do that, if you have ever moved a heavy object, you must have done this thing. You do that. For example, if we are pushing a car and we cannot push it with the vertical gesture, what we do is we bend our back, we lower our head, and the only purpose for doing that is we increase the component acting parallel to the road surface, and that is how we exert more force and we make the object move. Here's another way of looking at vectors. Now we can see that some vectors are vertical vectors, some are horizontal vector, and some vectors are in between vectors. Here are the 8 possible vectors actually. This one is vertical upward. This is vertically downward. Horizontal towards right, horizontal towards left. And there are 4 inclined vectors as well. As you can see, is the fourth form. 1, okay, here it is. 1, 2, 3, and 4. 4 inclined vectors that are in between the horizontal and vertical. Let's start from the simple one, the horizontal and vertical vectors. This one, let's name it 1. The 1 has all its power towards the positive y-axis. It is only, its y component is positive and its x component will be 0, because it has no intention, no part towards right or towards left. It is all vertical. And same we can say for this one, but there will be only one difference. Because it is pointing downwards, it will have y negative and x will be similar 0. No x component. Let's name it 2. Come to the third one. This is the third one. And this one has positive x with no y. It has no up or down component. No positive y, no negative y. Its y component is 0. Let's name this one 4. And now I think you are getting good in this, and you must be thinking that it is pointing towards left, so x should be negative and y is 0, because again it has no intention, no part going up or going down, so it is only a horizontal force, but it is towards left, and by convention we think the left is negative, because I have drawn this axis for you so you can relate it to this one. Okay, now let's come to inclined ones, tricky ones actually. This is the fifth one. It will have two components. One will be the horizontal component like this and the vertical component like this. Now if you have to guess the direction, like what should be the direction for horizontal component and what should be the direction for the vertical component, what will be your guess? What should be the arrow over here, towards right or towards left? As you can see, the original vector, this vector, is tending to the right and up, so it means its horizontal component should be towards right and vertical component should be up. So it will have a y component which will be positive, it will have x component which will be positive. Now come to the sixth vector. This is over here. This will have a component that is towards left and there is a component that is towards up. So what about x component? Is it towards positive x direction or negative x direction? We can see it is pointing towards left, so its x direction will be negative and the y direction will be positive. So yes, at this state I think you should pause this video and work out the directions of vector number 7 and 8 and see whether you get them right or wrong. The direction for the seventh one is down and to the left. So its y component is negative, its x component is also negative. What about this one? We can clearly see the x component is towards right. So its x is positive, but its y is negative. So it is very important to know the positive and negative of a vector. Why it is important for vector to be positive or negative, and why we need to be careful. Actually, in physics, we use positive and negative to distinguish between two opposite directions. And if it is a vector quantity, the only difference a vector quantity has from scalar quantity is its direction. And this is where we have to respect the direction of a vector quantity. And this will be the situation that will be given to you by the examiner in your exam, that he gives you two momenta in opposite direction. Two objects moving towards one another, and he gives you the speeds and you have to find the momentum, and at that state you have to be very careful that the objects are moving in two opposite directions and momentum is a vector quantity. You cannot assign both vectors or both momenta as positive, and you cannot assign a negative sign to both. It is a must that one is positive and other is negative. If quantities are in opposite direction and they are vector quantities, they cannot bear same sign. And that is the situation in this case as well. So wherever you see two vectors in two opposite directions, they must have two opposite signs. As you can see over here, x is positive over here, but in opposite direction it is negative. And if you want to think the left side is positive, no problem. You can think of left as positive. What will happen? As a consequence, the right will become negative then. Same goes for y. You can consider up as negative, that will make down positive. You cannot consider up and down both negative or both positive. This is where the problem begins. So be careful. Thank you for watching.